Hi guys, welcome to my first video. This is the first of a series where I'll be talking about propositional logic. In this video, I'll be going over the very basics and covering 3 points. The first is answering the central question of what is a proposition. The second is the basics of logical operators and their use in the construction of propositions. And the third is truth tables and how they help determining the outcome of propositions. First of all, what is a proposition? A proposition, simply put, is a statement. It does not matter if the statement is true or false, it just has to be a statement. So for example, 3 plus 3 is equal to 6 and 3 plus 3 is equal to 5 are both valid propositions. However, is it raining outside is not a valid proposition. Obviously, these are some very basic and not very useful examples, but their use is definitely highlighted in the use of computer science and mathematics. The second thing I want to talk about is the very basics of logical operators. What I mean by this is there is a set of 3 logical operators which can, in some combination, produce any proposition you want. So give a proposition, and in some combination of these 3 operators, you can represent that proposition mathematically. The 3 logical operators are or, and not. What do these operators mean? Well, the OR operator takes in 2 inputs, and the third thing is the output, or the result, or the outcome. And the outcome is dependent upon the inputs, much like how you add 2 numbers together and you get a result. With an OR operator, you get a result based on the 2 inputs as well. The OR operator takes in 2 inputs, and if either one of them is true, or if both of them is true, then the result is true. Similarly, the AND operator takes in 2 inputs, and if they are both true, only if they are both true, is the result true, otherwise the result will always be false. The NOT operator is quite simply a negation. So if the input is true, then the output is false, and if the input is false, then the output is true. Before we go any further, I want to talk about convention. So you can see on the screen now a number of different symbols which are used to represent these logical operators, and not only that, but you should also be able to see the different ways in which you can represent true and false. It doesn't matter which one you use. I've put a circle around the ones which I use so that you guys will know for the duration of this series which ones I will be using. But as long as you state when you start working on these things which convention you will be following, it does not matter. However, if you're doing this in a class or a module, then your lecturer may ask you to use a certain convention and you will have to follow that convention. The next thing I want to talk about is something called truth tables. Now, propositions can get very, very scary. You can have a ridiculously long proposition made up of 25 different statements, and that means that being able to determine the outcome based on a certain set of inputs can be ridiculously difficult. This is where truth tables come in. A truth table is very simply a table which provides a mapping of every possible input to an output. So you can think of it like a graph in maths. A graph in maths shows what happens when x is equal to 1, and when x is equal to 2, when x is equal to 3, when x is equal to 4. So you can see on the screen now the truth table for the logical operator AND. As you can see, the only time that the output is 1 is when both inputs are 1. Apart from that, the output is always 0 or false, depending upon the convention that you're using. Let's think about how I constructed this truth table. So I have a regular table. It has columns, it has rows, it has column headers. The 3 column headers are the 2 input and the 1 output, and as you can see, I have covered every possible combination of input. So they're both off, one is off and the other one is on, the other one is off and the first one's on, and then they're both on. That is every single input covered. And I've also given the output based on each set of inputs. What this means is that all you have to do is look up in your truth table the inputs which you are giving your proposition, and it will determine the outcome of that proposition for you. I'm going to cut the video here, but before next lesson, before next video, but whatever you call these things, before next tutorial, before next class, whatever, have a think about how you can do the same thing I've done with and, but for or and not. So, it's a little bit of self-study just to make sure that you understand what I've done. I will cover how to do it at the beginning of the lesson though. I hope you guys have found this useful. If you have, please be sure to like the video and subscribe if you want updates when the next video goes live. Alright, I'll see you guys in the next video. See you there.